is me, your teacher, Miss Mimi, and I will help you learn new stuff about math.
This is our math classroom, our virtual math class that will help you learn new things about math. Are you ready for our lesson? Okay, so here we go. Our lesson for today is all about union and intersection of sets. Our objective is that, after learning some introductory concepts about sets, a lesson in set operations follow. You will learn how to combine sets, which is union, and how to determine the elements common to 2 or 3 sets, which is called the intersection. In arithmetic, we have 4 basic operations, such as addition, subtraction, multiplication, and division of numbers. In sets, we have also the 4 basic set operation. In this lesson, we will only discuss the first 2 operations, namely the union and intersection of sets. The last 2 operations will be discussed in the next lesson. But before we proceed to our main topic, let's take a look at Anna and Jose's conversation first. Jose asked Anna, "What's your favorite food, Anna?" Anna replied, "I like burger, fries, spaghetti, ice cream, and cake. How about you?" "I also like burger and fries, but I like chips and fried chicken more." Okay, so let's list Anna's and Jose's favorites. Anna's favorites are burger, fries, spaghetti, cake, and ice cream. While Jose's favorites are burger, fries, chips, and chicken. Let's denote Anna's favorites as set A and Jose's favorites as set B. Given the 2 sets, set A and set B, I want you to observe box A, box B, and box C. Let's answer the following questions. Number 1. Which of the following shows the combination of set A and set B? Number 2. Which of the following shows the common elements between set A and set B? Let's have item number 1. Which of the following shows the combination of set A and set B? Is it box A, box B, or box C? I'll give you 5 seconds to answer. Timer starts now. Okay, time is up. So what do you think is the answer? That's right. The answer in item number 1 is box A. A contains the combination of the elements of set A and B. Therefore, A is the union of sets A and B, denoted by this symbol, read as A union B. Let's define union of sets. When we say union of sets, it is the set of elements that belongs to set A or set B or both. This is how we write union of sets in notation form. And this one is the symbol for union of sets. If we are to show the union of sets using Venn diagram, A union B is the shaded region. Now, let's have item number 2. Which of the following shows the common elements between set A and set B? Is it box A, box B, or box C? Again, I will give you 5 seconds to have your answer. Timer starts now. Time's up. So what is your answer? If your answer is box C, then it is correct. In item number 2, C contains the elements common to both sets A and B. Therefore, C is the intersection of sets A and B, denoted by this symbol, read as A intersection B. When we say intersection of sets, it is the set of elements that belongs to both set A and set B. This is how we write intersection of set in notation form, and this one is the symbol for intersection of sets. Again, if we are to illustrate intersection of sets using Venn diagram, A intersection B is the shaded region. So I guess you're ready to level up your learning about union and intersection of sets. Let's answer these 5 examples. Given the 3 sets, set X, set Y, and set Z, find number 1, X union Y, number 2, X intersection Z, number 3, Y intersection Z, number 4, X union Z intersection Y, and lastly, number 5, the quantity of Y intersection X union Z. Let's have the solution for number 1. The first thing you need to do is to list all the elements of set X and set Y. So these are the elements of set X and these are the elements of set Y. Finally, get the union of sets X and Y. This means that combine the elements in both sets. If an element is in both sets, we list it only once. Let's list first the elements in set X. So we have 2, 4, 6, 8, 10, and 12. Then, let's have the elements in set Y. So for set Y, let's list only the elements 3, 9, and 15 since 6 and 12 are found in set X. So we will no longer write the 2 elements. To make it uniform, if the elements of the given set are numbers, then arrange your final answer in increasing order. Therefore, the final answer for number 1 is X union Y is equal to the set that contains the elements 2, 3, 4, 6, 8, 9, 10, 12, and 15. Let's now proceed to number 2. The same for number 1. First, list all the elements of sets X and Z. So these are the elements of set X and set Z. Finally, get the intersection of X and Z. Note that the intersection is the common element. The common elements for set X and set Z are 4 and 10. Therefore, X intersection Z is equal to the set that contains 4 and 10. Let's have another example for intersection. Again, first, list all the elements of sets Y and Z. So these are the elements of set Y, and these are the elements of set Z. Finally, get the intersection of Y and Z. Note that the intersection is the common element. Since there is no common element in set Y and set Z, therefore, the answer is Y intersection Z is a null or empty set. Wow! Let's proceed to number 4. Same with the first 3 examples, list all the elements of set X, Z, and Y. So these are the elements of set X, set Z, and set Y. Second, solve the union of sets X and Z. Here is the answer to X union Z. As mentioned earlier, when we are getting the union of two sets, we will not list again the elements that occurred twice. In this case, 4 and 10 are found both in set X and Z. That's why we list them only once. After that, arrange in increasing order, so this is the final answer. The union of set X and Z is equal to the set that contains the elements 1, 2, 4, 6, 7, 8, 10, 12, 13, and 16. Let's write the remaining equation. Finally, solve for the intersection of X union Z and Y. Then here is the final answer. The elements common to X union Z and Y are 6 and 12. Therefore, X union Z intersection Y is equal to the set that contains 6 and 12. Now we're done to our last example. Let's have number 5. First, list all the elements of sets Y, X, and Z. So these are the elements of set Y, set X, and set Z. Second, solve the operation inside the parenthesis, which is the intersection of Y and X. The elements common to both Y and X are 6 and 12. So Y intersection X, which is the operation that can be found inside the parenthesis, is equal to the set that contains 6 and 12. Let's write the remaining equation. Finally, get the union of the sets Y intersection X and Z. Then here is the final answer. The union of the two sets is equal to the set that contains the elements 6, 12, 1, 4, 7, 10, 13, and 16. To make it uniform, if the elements of the set are numbers, then arrange your final answer in increasing order. Therefore, the final answer will be the quantity of Y intersection X union Z is equal to the set that contains the elements 1, 4, 6, 7, 10, 12, 13, and 16. Now, I have a challenge for you. Given the three sets, set X, set Y, and set Z, find number 1, X union Y union Z, and number 2, X intersection Y intersection Z. For number 1, I have here a hint. List all the elements found in the three sets. Take note, if an element is found in 2 or 3 sets, list it only once. Don't forget to arrange your final answer in increasing order. And the hint for number 2, find the common elements found in the 3 sets. Take note, common elements should be found in all 3 sets, not in 2 sets only. Good luck! I will reveal the answer on our next video. So that's all for our lesson on union and intersection of sets. Hope you learned something new today. Stay tuned for more videos here in the Math Classroom. That's all for today. Goodbye, class. See you in our next video.